Hello friends, this video on Organic Chemistry Basics part 20 is brought to you by examfear.com. No more fear from exam. What are nucleophiles? As the name suggests, nucleo and phile. So nucleo means nucleus and phile means love. So the agent which loves nucleus are called nucleophile. Since they love nucleus and nucleus is nothing but positive charge because it has protons, so they should be positively charged or neutral, possible also, but generally they are negative charge. Why? Because they love nucleus and nucleus is positive charge, or they are neutral also. Correct. So if you see, nucleophilic is nothing but it describes the affinity of a nucleophile towards nucleus. We'll take some examples. So the definition of nucleophile is it is a chemical species that donates electron pair. Why they donate electron pair? If you see, the nucleus is electron hungry, right? So nucleus is saying, if you want to come near me, you have to give me electrons. So this guy is saying, since I love you so much, I love nucleus so much, I am ready to give electrons. I am ready to donate electron pair, and thus I am a nucleophile. So this guy is ready to donate electron pair to nucleus because nucleus is electron hungry, and this guy says, I love you, I love nucleus. So since this guy want to be near nucleus, this guy is ready to donate electron pair, and when they donate electron pair, they form a chemical bond. We'll see that. And since this nucleophiles donate electrons, they are also called Lewis base. So if you see the definition of Lewis base, which we have studied in the chapter of atom, Lewis base are the chemical species which donate electron, and since this nucleophile donate electron, they are Lewis base. Correct. This is my typical nucleophile which has which loves nucleus, and the only thing in his mind is the nucleus. It want to go near nucleus. Correct. So if you see, the molecules are ion with free electron pair. They should have either a free electron pair or one pi bond. Can also act as nucleophile. Example, Cl minus, if you see, it has electron pairs. Br minus also has electron pair. Cn minus also has electron pair. So if you see Cn minus, it has electrons extra. And if you see OH minus, it also has extra electron negative charge. NH3, if you see, it has a lone pair of electron donate. Correct, extra. If you see water also has this guy, extra electrons to donate. So if you see water and ammonia, they are neutral, but still they are nucleophile because they have free pair of electron. As I told, the one with the pi bond, this guy, if you see, ethyne, this guy has pi bond, and this pi bond is nothing but electron cloud. They are electron rich cloud, right? Here if you see, this guy is electron rich cloud like this, right? And since they are electron rich, they can also be a nucleophile. Correct. This is also, if you see, ethene can also be nucleophile because here we have one electron cloud. So typical example of a nucleophile you see is Br minus, OH minus, Cn minus, ethene, ethyne. In fact, benzene also has electrons, the pi bond, so extra electrons. Benzene can also donate electrons, so it also acts as a nucleophile, but rarely because of the big size. Water, ammonia. So all these are my examples of nucleophile. And if you see here, this alcohol, this ether, and these amines, they also act as a nucleophile. Correct. So you see, this is a ethene, and it also has lone pair of electron to donate. So since it has lone pair of electron to donate, it also acts as a nucleophile. So now we have talked about nucleophiles. There are so many nucleophiles: Br minus, Cl minus, OH minus, Cn minus, or the ethyne. But the question is, which is a strong nucleophile, which is a weak nucleophile, right? Because when you talk about nucleophiles, you should know which one is a strong nucleophile, which one is a weak nucleophile. It is very critical in the organic reaction. You should know which one is a strong and which one is a weak attacking reagent. So the logic is pretty simple. The greater the hungerness for this guy to attach to nucleus, the greater is the the greater the strength of the nucleophile, or the greater the capacity of these guys to donate electron, the greater is the strength of nucleophile. So there are typically 4 factors that contribute to the nucleophilicity. The first one is the charge. So if you increase the charge density, please note, I'm talking about the electron density. Increase the electron density, that means this guy has more and more electrons, right? Electron density is electron per unit size, that means compared to whatever size it has more electrons. Then the nucleophilicity character will also increase, right? Because if the electron density is increased, the capacity to give electron also increase, and thus the nucleophilicity also increase, correct? So if you see in this case, OH minus NH2, if you compare, right? So this guy has more electron density, OH minus, as compared to water. So OH minus is a stronger nucleophile as compared to water, correct? Similarly, NH2 minus has more charge or electron density as compared to amine NH3. So this guy NH2 minus is a stronger nucleophile as compared to NH3. Similarly, HS minus has more electron density as compared to HS. So HS minus is a stronger nucleophile, correct? Also, if you see fluorine, chlorine, bromine, iodine. So this, if you see fluorine, chlorine, if you go down the group, right, the size increase. See, this is my fluorine, this is my fluorine, this is my bromine, right, and this is my iodine. But the charge is all same, 1 unit charge. So I'm talking about the electron density. So electron density is maximum in fluorine, right? Density is what? Density is charge by volume, right? So if you see going down the group, the size increase. Size is increasing, volume is increasing. So this charge is constant in all this -1, but the volume is increasing. So if you go down the group, the electron density decreasing, right? The number of electron is same, or because the extra negative charge is same, right? But the electron density is increasing. Since the electron density is increasing, the nucleophilicity increases. So fluorine F minus is more nucleophile than Cl minus, than Br minus, than I minus. The second factor is the electronegativity. So it says that as the electronegativity increase, the nucleophilicity decrease. Why? See, the electronegativity increase, that means that particular species wants to hog more electron, wants to grab more electron, right? That means it will not be able to give electron, correct? See, electronegativity increase, that means that that particular species want to get more electron. So it will not give electrons. For example, carbon is fluorine is the most electronegative here. So fluorine wants to get electron, fluorines won't give electron. Carbon is the least electronegative, right? So carbon is okay to give electron. So in this case, this is most electronegative. Electronegative. This guy is most electronegative, right? This is most electronegative, and this guy is most stronger nucleophile, correct? So if you see, carbon is the least electronegative and carbon is the most stronger nucleophile, because carbon has the least electronegativity. It is okay to give electrons. Since it is okay to give electron, it is good nucleophile, because nucleophile is nothing but the one which gives electron. Why? Because the nucleophile is one which loves nucleus, and nucleus says I want electrons. So if you want to love me, you have to give me electron. So nucleophile is the one which gives electrons. If you see, CH3 minus is more strong nucleophile than NH2 minus, then OH minus, and that. Similarly, if you take this particular period, silicon SiH3 minus is stronger nucleophile than PH2 minus, than SH minus, than Cl minus. It's correct. So this is my period 3 and this is my period 4. This is my third period and this is my fourth. So this is my second period, right? This is my second period, this is my third period. Hydrogen, helium, and this is my lithium, beryllium, boron, carbon, nitrogen. This is my second period and this is my third period. The third factor which determines the strength of the nucleophile is a solvent. Yes, it is solvent. Please don't ignore the solvent. solvent also plays a critical role. So as we know, there are two kinds of solvents, protic and aprotic. In fact, we'll discuss more about the solvent in the next few slides. So if the solvent is polar protic, it plays a critical role for the nucleophilic strength. So if you see polar protic solvent, I can give some examples to you if you want. So they are, example, water is a polar protic solvent. My alcohol, or you can take amide, these are my polar protic solvent. Now what happens is, so if you have the nucleophile, right, and you put in water if you see is H2O, oxygen has slight negative charge and this guy has slight positive charge. So this guy will get attracted to this guy, nucleophile. And now similarly, water molecule, what it will do is, it will hog this, it will in fact clutter this nucleophile. It will, right? So with this, because of this, the nucleophile won't be able to function properly. Hope you are understanding what I am trying to say here. So if you see this is water molecule, right, because of hydrogen bonding and this the plus charge on slight plus charge on hydrogen, it will hog this particular nucleophile, right? So this nucleophile is trapped in this water molecule, and with this the power of this nucleophile is decreased. If you see, that's why if you have a polar protic solvent like this, the nucleophile strength is reversed. As I saw, the fluorine has the highest nucleophile strength normally because fluorine has the highest charged density, electron density, correct? But the moment you put in polar protic solvent, the fluorine is trapped the most. The whole fluorine is trapped the most, then the chlorine, then bromine, then iodine. Correct? And why? Because the abilities to participate in hydrogen bonding decrease as we go down the period. So these, if you see, these are all fluorine, chlorine, bromine, iodine. These are all down the period elements for the same group. Correct? So what I'm trying to say here is, if you go down the group, the tendency to form hydrogen bond decreases. This guy has maximum tendency to form hydrogen bond, fluorine. So fluorine is trapped the most, iodine is trapped the least. Since fluorine is trapped the most, fluorine becomes weak. And since iodine is trapped the least, iodine becomes strong. Correct? So in normal case, the fluorine is the F minus the strongest nucleophile, but the moment you add a polar protic solvent, the trend is completely reversed. Please note here, this is a critical point here. So in case of protic solvent, the strength of nucleophile is totally reversed. But in case of polar aprotic solvent, you don't have to worry much about it. So protic solvent is one which gives H plus ion. So we will discuss more about this protic and aprotic solvent. And aprotic doesn't give H plus ion. And then the fourth factor is the steric hindrance. So this will also impact the, so for example, if this is my bulkier group, right? This is my bulkier group. This is my light group, which has only hydrogen attached in this carbon. This is my light group. So this is my strong nucleophile. In this, if you see, I have 1, 2, 3 carbon attached, right? 3 methyl group attached. So this becomes my slow or very weak nucleophile. Correct? For example, let's suppose I have CH3I. This is my substrate. In this, and let me add this guy, CH3O minus. This is my nucleophile. So with this, if you see, the reaction will be what? One hydrogen or iodine will be kicked out. So this guy will kick out this iodine. So this will become CH3O, CH3, and iodine will be taken out. Since it is a very strong nucleophile, this reaction will be very fast. For the same substrate CH3I, if I add this guy, that is, you see this guy as my nucleophile, right? So what this guy will do? This guy will also attack this iodine, right? And it will form CH3O and then CH3, 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 correct? Plus I minus. But this reaction will be very slow, very slow. Why? Because this particular nucleophile is very weak nucleophile, and this is a strong nucleophile. See, this is a weak nucleophile, and this is a strong nucleophile. Strong nucleophile. Correct. So steric hindrance also plays a critical role in finding the or determining the strength of a nucleophile. So if you want to focus more on the aprotic solvent, I can give you some example of aprotic solvent. Aprotic solvent can be acetone, right? Then dimethyl sulfoxide, we call DMF, dimethyl sulfoxide, or ethane nitrile. So these are my aprotic solvent. You can take one reaction also, protic and aprotic solvent. As I told, right, for iodine, in protic solvent it is very fast, and in aprotic solvent it should be very slow because it will follow the normal reaction, right? So let's take one reaction with iodine. So let me take my substrate to be C2H5Br, right? And let me react with I minus, right? Because I minus is my nucleophile here. And let me have the same thing also here. Two reaction. In first case, let me have a protic solvent. So protic solvent can be alcohol. Let me take methanol. Methanol, right? And this is protic. The next case, let me take aprotic. Let me take acetone. This is aprotic. So what will happen? So in protic solvent, what is the expected behavior? Iodine is, I minus is a very strong nucleophile. So what will happen? So this will form C2H5I and it will kick out Br minus, right? This guy will do this. And this will be very fast reaction, very fast reaction. We'll discuss this reaction. This is a substitution reaction. We'll discuss the type of reaction also. Later, just understand that this reaction will be very fast. In this case also, you will form the same product, but the reaction will be very slow. Why? Because in this case, the iodine becomes a weak nucleophile. This guy here, it is a weak nucleophile, right? And this guy here is a strong nucleophile. Correct? So the same nucleophile I minus is a strong nucleophile in one case and weak nucleophile in one case. So if you see, the strength of nucleophile depends on a lot of factors. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.